In this problem, we're adding heat to this chemical toluene. So we want to see how much the temperature goes up. So it says toluene has a specific heat of 1.13 joules per gram per Kelvin. That's how toluene absorbs heat. So we want to know what temperature toluene will be raised if 35.50 grams of toluene starting at 25.15 degrees Celsius is heated with 1125 calories, and it tells us how many joules in a calorie. Okay, so heat. We know that if we heat a substance, many times it will raise the temperature. So that's what we're doing. So heat is given the symbol Q, which is equal to the mass of the substance. Obviously, it takes more heat to heat more mass, times the temperature change, times what we call C, and that is C, the specific heat. So every substance absorbs heat differently, and toluene, it takes 1.13 joules of heat to raise the temperature of 1 gram of toluene 1 Kelvin, or, as you know, 1 Kelvin is equal to 1 degree Celsius. So we know that Q equals 1125 calories, but we need to change that to joules, and we're given the conversion over here. So that's 4.18 joules for every 1 calorie. So that equals 4,703 joules of heat that are absorbed. Okay, the mass, we know what the mass is. That's 35.50 grams. And C, that's our specific heat. That's 1.13 joules per gram per Kelvin. And in this case, we could substitute degrees Celsius for Kelvin. And so what we're looking for really is the change in temperature. We know the initial temperature, we know the initial temperature is 25.15 degrees. And so that's going to be TF minus 25.15. So TF is going to equal delta T plus 25.15 degrees Celsius. So we're going to first use this equation up here, and we're going to solve for delta T, and then we're going to plug delta T in to the bottom here and solve for TF. Okay, so Q equals M times the change in temperature times the specific heat, and we're going to solve for delta T. So we'll rearrange that and say that delta T is equal to the total heat, which was 1125 calories, which we changed to joules, divided by the mass, divided again by the specific heat. So the change in temperature is going to equal 4,703 joules, divided by the mass, which is 35.50 grams, divided by the specific heat, which is 1.13 joules per gram per Kelvin. And remember, the magnitude of 1 degree Celsius is the same as a Kelvin. So delta T is going to equal 117 degrees Celsius. All right, so now we're going to plug that back in here. TF is going to equal 117 degrees Celsius plus 25.15 degrees Celsius. And so with the right number of sig figs, that's what we get, 142 degrees Celsius. So again, We know that heat can cause a rise in temperature, and the rise in temperature depends on the mass and the specific heat, and so we can rearrange that equation to solve for the temperature change, and then we could plug that in and figure out the final temperature.